Wastewater contains organic matter, solids, pathogens, and nutrients. These materials must be removed to protect public health. A variety of pretreatment components can be used with a drip dispersal system. Septic tanks provide primary settling of the solids in the wastewater. Aerobic treatment units, sand filters, recirculating media filters, and constructed wetlands use microbes living in the device to further treat the wastewater before it enters the pump tank. Wastewater entering the soil can still contain organic matter, solids, pathogens, and nutrients. The soil acts as a final treatment component, removing those remaining contaminants. The emitters control the flow rate of the water entering the soil. This low flow rate, combined with a controlled dosing frequency and length, allows the wastewater to move through the smaller soil pores under unsaturated conditions. This movement through small soil pores allows remaining solids to be filtered out. It also allows organic matter and pathogens to be absorbed onto the biomass growing on soil particles. Since wastewater is moving through the small pores, the larger pores remain filled with oxygen-rich air. This combination of oxygen, water, and contaminants from the wastewater provide excellent growing conditions for soil microbes. These microbes provide the final treatment of the organic matter, solids, and pathogens. Landscape plants growing on top of the drip dispersal field recycle the remaining nutrients and reduce the risk of groundwater contamination. The design process begins with an assessment of the site's treatment capability. Consideration must also be given to the expected use of the facility and the treatment needs of the watershed. The quantity of wastewater generated in a home is estimated from the number of bedrooms or the square footage of a residence. However, occupants and their activities can greatly affect the flow, quantity, and rate. For example, doing all the laundry on one day causes a high flow rate that can impact the system. It is important to evaluate this and similar resident habits to get an accurate estimate of wastewater discharge. Design and placement of the drip field requires a number of special considerations. The pretreatment and land application components are then selected and matched, both to each other and the site. The size of the pump tank is based on the expected flow variance and the emergency storage requirements for the system. The pumps used to dose residential drip fields are high-head pumps. These pumps are generally very similar to water well pumps. They provide a pump flow of approximately 12 to 20 gallons per minute. The controller is another important piece. It controls the frequency and time of dose. If the dosing time is too long or the rest time between doses is too short, water may be forced to the soil surface. Therefore, dose and rest time must be matched to the site's soil conditions. Proper design and placement of the drip field requires a number of special considerations. The soil's ability to accept and treat wastewater is a key factor in determining the size of the drip fields. Generally, a sandy soil accepts water faster and requires a smaller drip field than a site with clay soils. Placement is equally important. The drip field is designed to treat wastewater, not rainwater. Rainwater coming from driveway, roofs, and other impermeable surfaces upslope from a field should be diverted. A field flooded with rainwater has little capacity for managing wastewater. The drip fields are placed into the landscape so the laterals run across the slope following the contour. This means the supply and return manifolds are then running up and down the slope. The ideal maximum length of laterals is determined by the type and spacing of emitters and ranges from 200 to 400 feet in length. Drip laterals are generally installed in parallel lines 2 feet apart. Emitters are placed in the drip tubing every 12, 18, or 24 inches. This forms a grid pattern for application of the wastewater into the soil. For a drip field to remain unsaturated, emitters and laterals must be spaced properly. If they are too close together, problems can occur. If your field area is restricted within the landscape, you may opt to have multiple fields or zones. Drip laterals are installed at depths ranging from 6 to 24 inches, with the most common depths in the range of 8 to 12 inches. The real benefit of a drip dispersal system is to place the water into the active growing zone in the soil. This allows plants to use the water and nutrients. The goal is to place the drip laterals as shallow as possible, but prevent wastewater from coming to the soil surface during a dosing event. The inclusion and placement of air relief valves is critical. Valves are installed on the supply and return manifolds at the highest point in the field. At the end of the dosing cycle, the valves allow air to enter the drip laterals as the water slowly drains from the emitters. Without air relief valves, a vacuum develops, causing soil to be sucked into the upper emitters and plug them.